Vanakkam. Today we are going to solve problem 3.19 using nodal analysis from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. Using nodal analysis, we have to find V1, V2 and V3. This symbol indicates we are asked to solve this using MATLAB. We are going to solve manually only. Okay. So this is the circuit. So for this, we mark the current directions, or we assume the current directions. So this is I1 current, this is I2, I3, I4, and here we have I5, and this is I6. And here we have two current sources, that is 3 amps and 5 amps, and one voltage source is available. Okay, so here we have first node, second node, third node with the potentials V1, V2, V3, and this is the reference node. Okay, so now let's get started. At node 1, we'll apply KCL. So here the incoming currents for this node 1 is this 5 amps current is incoming, and then other currents are leaving currents only. Okay, so this is equal to this I1 current plus I2 plus this I3 current, and then plus this 3 amps current. These are all leaving currents. Okay, so now we apply Ohm's law for this currents. So this I1 can be written as V1 minus 0 potential divided by this 4 plus this I2 is V1 minus V2 divided by this 8 ohm resistance plus I3 is V1 minus V3 divided by this 2 ohm resistance plus this 3 amps. So this 3 can be brought to the side, so you can write this as 5 minus 3, that is equal to, and here we take the common denominator as 8. So it is 2V1 plus V1 minus V2 plus 4V1 minus 4V3. So then you can cross multiply this. So it is 2 into 8, right? So it is 16, that is equal to 7V1 minus V2 minus 4V3. So this can be rewritten as 7V1 minus V2 minus 4V3, that is equal to 16. This is our first equation. So now we are going to apply KCL at node 2, Kirchoff's current law. Okay, so here the incoming currents, that is I2 alone is incoming, and the summation of outgoing currents, that is I4 and I5. So this I2, for this we can apply Ohm's law, so it can be written as V1 minus V2 divided by 8, that is equal to I4. I4 is V2 minus 0 potential, right, divided by this 2 ohm plus I5 is V2 minus V3 divided by 4 ohms. So here it is V1 minus V2 by 8, that is equal to, on this side if you take 8 as common denominator, it is 4V2 plus 2 times V2 minus 2 times V3. So this 8 and 8 get cancelled. So we can write this as V1 minus V2 minus 4V2 minus 2V2 plus 2V3, that is equal to 0. So it is V1 minus 7V2 plus 2V3, that is equal to 0. This is our second equation. Now we are going to apply KCL at node 3. So here what are the incoming currents? This I5, I3 and this 3 amps and the leaving, this is also incoming. So all the currents are incoming for this node 3. So for this third node, I5, I3, this 3 amps and this I6, all these currents are incoming currents. So we can write this as 3 amps plus I3 current plus I5 current plus I6, that is equal to 0. So 3 plus what is I3? It is by applying Ohm's law, it is V1 minus V3 divided by 2 ohms plus I5 is V2 minus V3 divided by 4 ohms plus I6 is, at this point we have this plus 12 ohms. Okay, so it starts from there only. So it is 12 minus this V3 divided by 8, that is equal to 0. Okay, so this 3 can be brought to the side. So for other terms we can take the common denominator as 8. So it is 4 times V1 minus 4 times V3 plus 2 times V2 minus 2 times V3. Then here we have plus 12 minus V3, that is equal to minus 3. Okay. So when we cross multiply this, okay, so here it is, how many V1s we have? 4 V1 so it is 4 V1 plus 2 V2 minus 7 V3, that is equal to, this is minus 24, this 12 also coming over here as minus 12. So we have this as 4V1 plus so it is 4V1 plus 2V2 minus 7V3, that is equal to minus 36. So this is our third equation. So we have the three equations formed. Now we are going to solve this using matrix. Okay, so first we'll write 7 minus 1 minus 4. Here it is 1 minus 7, this is 2, and this is 4, 2 minus 7. So this is multiplied by this V1, V2 and then V3. Okay, so that is equal to, here we have 16, 0 minus 36. Okay, now we'll find the delta for this. So del is equal to 7 into, this is minus of minus, so it is 49. Then here this is 4, that means minus 4. And then this minus 1, already minus of minus plus 1 multiplied by, so here this 7 minus 7 into 1, so it is minus 7. This 4 into 2, so it is minus 8. Then plus this minus 4 sign is there. So here we have minus 4, that so it is minus 4 multiplied by this 2 minus, already here minus is there, so minus of minus plus 28. So this is equal to 7 into 45 plus 15, that minus sign, okay. So it is minus 15, then minus 4 into 30. Oh, this is equal to 315 minus 15 minus 120. So this 180. So delta is equal to 180. Okay. So now we want to find out V1. So V1 is del V1 divided by del. V1 is equal to del V1 divided by del, isn't it? So it can be written as, here it is 16, 0, minus 36. Then here you have minus 1, minus 7. This is 2. Then minus 4, 2, minus 7. Okay. Divided by del value is 180. Okay. So this is equal to 16, then multiplied by this 49 minus 4, then plus minus of minus plus 1. So here it is minus of minus 36 into 2, so it is 72 minus 4 into minus 252. So this is minus 4, then this is 0, this is minus, because this minus minus get already cancelled, so we have the minus 36 into 7, that is 252. So this is equal to 16 into 45 plus 72. This is minus of minus plus 1008. We are finding here this del V1, okay. So it is 720 plus 72 plus 1008. So we get this as 1800. So this V1 is equal to del V1 divided by del. So it is 1800 divided by 180. So that is equal to 10. So V1 is equal to 10 ohms. So this is one answer we get. Okay. Now we need to find out V2. V2 is del V2 divided by del, right? So it is, the determinant values 714. The second column is replaced. Okay, so it is 16, 0, minus 36. Third column as such. So minus 4, 2, minus 7. So it is divided by the delta values in it. So it is 180. So this is equal to 7 into, here it is 0, so minus of minus becomes plus, right? So it is 72. Then this is 16, so minus 16. Here it is minus 7. This is 8, that is minus 8. Okay. Then again this is minus 4 multiplied by, this is minus 36, then 0, minus 0. So this is equal to 504. Then this is 15, minus 15 into minus 16. So it is plus 240. 240. Then this is minus plus 4 into 36. It is 144. Okay, the whole value divided by 180. So this value is 888 divided by 180, that is equal to 4.933 volts. So this is our V2. Okay, so we got the second answer, 0.933. This much volt. This is our second answer. So now we want to find out V3. V3 is del V3 divided by del. So del V3 is 714. Then here we have minus 1, minus 7, then it is 2. Here we have 16, 0, minus 36. Okay, that divided by del is 180. Okay, so here we have, this is 7 into 36 minus 7 into minus 36, that is becoming plus, right? So I'll find it out. Then this is 0. Okay, then minus 1, already minus of minus plus 1 into, here we have this minus 36. Okay, then here it is 0, right? Then here we have plus 16, then here it is 2, then minus of minus 20 plus 28. So this is equal to 7 into 7 into 36, that becomes 1764. This is minus 36, and this is 30 into 16, so that is 480. So then divided by 180, right? So this is equal to 2208 divided by 180. So that V3 is equal to 12.267 volts. So we got the third answer also. So we got all the three answers. V2 is how much? 12.265. And what is V1? V1 is equal to 10 ohms. So we got all the three answers. Okay, thank you.